In this presentation, I will present work performed by the company Crosslang in the framework of the ELRC action, which is coordinated by DFKI. With the European Language Resource Coordination Action, the European Commission has taken a decisive step towards minimizing language barriers across the European Union through various types of activities: data collection, setup of a help desk for data providers, awareness raising, and assessing tools and techniques in specific LT areas. Within ELRC, the assessment of tools and techniques involves documenting them in a hands-on manner and performing corresponding tests and experiments in order to inform EC staff and EU member state representatives about the feasibility and impact of such technologies. We present two language technology assessments as part of the ELRC action, namely the automated anonymization specification and the multilingual fake news processing specification. First, we motivate ELRC's anonymization specification, describe tools and techniques, discuss the consultation round and its findings, identify scenarios for anonymization, and provide details on the proof of concept software. The process of anonymization consists of removing personal identifiable information. It involves removing elements that can be used to identify a person, for example, names, account numbers, mortgage amounts, etc., in a way that the resulting data cannot be associated with any individual. This process is also referred to as de-identification of data. While anonymization focuses on the removal of personal identifiable information, pseudonymization involves the replacement of a named entity or pattern by another element, a pseudonym. From a technical point of view, when automating processes, the term anonymization carries the same meaning as pseudonymization, but they have a different meaning from a legal point of view. In contrast to pseudonymization, anonymization involves the irreversible altering of personal data in such a way that the data subject can no longer be identified directly or indirectly. Anonymization is particularly important when it comes to the sharing of language data. For instance, in case an organization wants to store data and share it with other organizations without violating the General Data Protection Regulation, or in case data shall be processed and used for training a machine translation system. In the context of the ELRC action, we investigated the anonymization of unstructured textual content, rather than structured textual content in databases or spreadsheets, in which the fields and cells typically identify the type of information unambiguously. Looking at unstructured content, anonymization involves two steps. First, detecting what should be anonymized via a named entity recognition system, and secondly, determining how it should be anonymized, either via blackening named entities, replacing named entities with a label indicating the type of information, or replacing named entities with a similar word. In the next slide, we illustrate these replacement strategies with an example. After detection of the named entities in the original sentence, in this case Jamie, Alice, TextCorp, and Monday, we can either blacken these named entities as shown in option 1, or we could choose to replace the named entities with a label indicating the type of information. Finally, we could choose to replace the named entity with a similar word. For example, replace a person's name with another person's name. The consultation round consisted of organizing meetings with central stakeholders concerned with automated anonymization in order to collect requirements and feedback from a variety of sources and application areas. The consulted stakeholders are the following. They are consortia of projects related to named entity recognition and anonymization, such as MAPPA, ELG, and Comprise. Translation technology experts. Domain experts, for instance, in the field of anonymizing police reports and health-related texts. Digital service infrastructures of the European Commission, deploying trans-European digital services in various domains and showing an interest in the anonymization of their data. And finally, the Language Resource Board of ELRC. The main findings of these stakeholder meetings are that sensitivity of the data to be anonymized has an influence on the choice of replacement strategy, that the choice of the replacement strategy depends on the downstream use, that most anonymization tools and techniques involve monolingual data, and that the user of an anonymization system needs sufficient control on the de-identification process, for example, by specifying a list of named entities to be replaced and by manually correcting via an editor. Based on the findings, a number of basic and advanced scenarios in the area of anonymization were identified. One basic scenario, illustrated in the figure, involves a workflow in which a document is processed using named entity labels. The document, for example a docx file, is pre-processed by separating text and layout. The text is segmented into sentences, and the sentences are anonymized by running a deep learning model for named entity recognition. The workflow also consults a list of named entities and regular expressions specific to the organization in question. The text parts identified as named entities are then replaced by named entity labels, resulting in anonymized text and, if needed, a mapping table. The sentences may be manually reviewed. Finally, the sentences can be recombined into paragraphs and the layout added to them, so the resulting document can be archived or shared with other organizations. Another basic scenario consists of a workflow for processing documents with high sensitive data. This workflow proceeds in a similar fashion as in the figure shown here, but involves replacement of some named entities by other named entities in order to reduce the risk of de-identification. The third basic scenario consists of anonymizing translation memories by checking source and target sentences separately or in combination. A more advanced scenario consists of training an application from anonymized monolingual or bilingual data, such as the machine translation system or a summarizer. This may require customized ways of annotating training data and input. Finally, when dealing with a highly domain-specific text, it could be necessary to retrain a named entity recognition model with an appropriate set of named entity labels. In order to demonstrate the identified basic scenarios, we set up a proof of concept software in the form of Docker images and the user interface addressing those. The Docker images integrate three publicly available tools, namely TM Anonymizer, developed in the Ceph Data Marketplace project, Text Transformer, developed in the H2020 project Comprise, and ByRoamer, which is part of the ByTexter package. The Docker images also add new functionality to the tools. Support for document formats like docx, for formats storing bilingual data, for user-specified named entity lists and patterns, for viewing the mapping table, and for obtaining a detailed logging of the commands run in the background. The Dockers and the UI will be provided on a GitHub repository. Now we focus on the multilingual fake news processing specification in ELRC. First, we will motivate the specification. As it is work in progress, we provide a general description of the relevant tools and techniques, the consultation round, and experiments that will lead to proof of concept software in the course of 2022. In an increasingly digital world, disinformation on various topics is spreading quickly at a much faster rate than accurate information. Disinformation consists of false information with the intent to manipulate, spread, and cause harm. Because of the quick spreading rate of this information, the availability of tools for automatically detecting it and making readers aware of the potential harm of this content is gaining urgency. Moreover, as this information is a global phenomenon, it is important to explore to what extent multilingual coverage has been or may be reached in the area of fake news processing. This multilingual aspect is explored as part of the ELRC action. The fake news detection task consists of classifying news articles as true news, authentic news, or fake news, or assigning a score to a news article indicating the trustworthiness of the article. The fake news detection task should not be confused with fact-checking, a closely related task in which an expert or journalist is asked to judge whether a specific claim in a news article or social media post is correct based on evidence. Specific methodologies exist and model architectures for this more challenging task. Nonetheless, models for fake news detection may also be helpful in order to speed up the process of fact-checking by flagging articles potentially containing false claims. Several architectures for fake news detection were proposed in recent years, following the advances made in the more general field of text classification. Use of shallow linguistic features extracted from news articles, combination of pre-trained word vectors with various types of neural networks, and use of BERT pre-trained language models. In the consultation round, stakeholders with various profiles are being consulted. A major stakeholder is the European Digital Media Observatory, a partnership between various organizations that provides a collaboration platform bringing together fact-checkers, journalists, etc. Other meetings in the consultation round involve stakeholders from academia and industry working on automated approaches to fake news detection. In addition, fact-checking organizations are being approached in order to shed light on the procedures they apply for manual fact-checking and the tools they make use of. The provisional main findings of the ongoing meetings are the lack of multilingual resources for detection of fake news and the quick evolution of fake news topics. Also, the consulted fact-checking organizations indicate they do not use fake news detection tools in their current fact-checking pipeline. We are performing both supervised and unsupervised experiments for fake news detection. The supervised models are trained on a labeled set of fake and true news articles, and the unsupervised models are only trained on true news articles. Concerning supervised classification, we use an approach in which features inherent in the text are combined with other features. Our classifier takes as input the text itself as well as categorical and numerical features like Alexa rank, a measure of best website popularity. The classifier predicts whether an article is true or fake news. Due to the lack of large multilingual datasets for fake news processing, we propose the use of machine translation for obtaining multilingual model. An English set of labeled news articles is translated to a language of choice, such as French or Russian, after which the classification model is trained on the concatenation of the English, French, and Russian training sets. As for unsupervised classification, we have set up a novel approach which aims at training a model merely on articles known to constitute true news in order to tackle data sparsity. This approach applies a technique called one-class classification or anomaly detection, which is already being used in the field of computer vision and natural language processing. We applied an existing algorithm called context vector data description in a multilingual way by aligning vector representations. By training a one-class support vector machines model on the obtained anomaly score and a set of features extracted from news articles related to punctuation, readability, and syntax, we built an anomaly detection model that is merely trained on true news articles. At inference time, articles which are anomalies according to the model are considered fake news. When evaluating our architecture for the supervised multilingual models, we observed that good classification results can be achieved when training and evaluating on English, French, and Russian data. Moreover, we observed that our models achieved similarly good results in a zero-shot setting. For the unsupervised models, our current observations indicate that, despite the fact that the training process only makes use of true news articles, promising performance can be achieved. Interestingly, we also observed zero-shot potential for these types of models, especially for closely related languages. We now move on to our conclusions. 2 language technology assessments were presented that are part of the ELRC action of the European Commission. A consultation round was performed for both automated anonymization and the multilingual fake news processing specifications. Proof of concept software for the automated anonymization will be made available on GitHub. For the multilingual fake news processing specification, we presented a methodology for both supervised and unsupervised fake news detection. The proof of concept software is under development. Thank you for your attention.